This is gosh, I think it's our 15th year in a row that we're doing a Monsoon Outlook. And each year they get a little more exciting, I think, because we try and add some new details. And the flood warning branch staff continues to grow, and we have some great young up and coming talent. And so I guess with that, we're going to take an opportunity. We'll do our Monsoon Outlook. We'll do a little monsoon safety for you new folks. What is the monsoon? But with that, let's get started. Hannah's going to start out with what is the monsoon and monsoon safety tips. Thank you.
Great, yeah, thank you. Thank you, everybody, thank you. Happy to be here. Thank you, everyone, for coming. It's always exciting to talk about monsoon, so I'm gonna just get right into it. All right, I'm gonna get started with monsoon science. So first of all, what is a monsoon? I hear it all the time. This monsoon hit my house last night. Monsoons rolled through the valley. Unfortunately, that is the incorrect terminology. A monsoon is not a thunderstorm. I say it again, we say it all the time, us meteorologists, we kind of clench our fists when we hear it. So I'm just gonna pound it in right now. A monsoon is a seasonal wind shift that can then affect regional precipitation. There's monsoon climates all over the world, including our very own North American monsoon right there. How does a monsoon circulation form? It all starts with the sun. When spring turns into summer, when the sun's higher up in the sky, you have increased solar radiation. That heats up the surface, it heats up the ocean. And our area specifically, the proximity to the Eastern Pacific, to the Gulf of California, to the Gulf of Mexico is really important. So when that sun shines, it heats up the land actually quicker than it does the water. And that creates a sort of an imbalance. The air at the surface on land that's warming up quicker, it warms up, it expands, and it's less dense. Because it's less dense, it can then rise. That creates a low at the surface over that land. And then when you have a higher pressure over the water, air naturally wants to move from high pressure to low pressure and starts the circulation pattern, which then pulls in probably the most important thing when it comes to monsoon season. What we need for storms is moisture. So you have that transport starting at the surface, and then when you go even higher up in the atmosphere, it creates an upper level high pressure system. So low at the surface, high, and it literally is it's a self-serving cycle and just starts going and it keeps on going, and that's how we get our thunderstorms that we know and love. And you'll see this right here. That's that coupled monsoon circulation, surface low, upper level high. So you looked at it from the vertical standpoint. Now let's look at the geography of it. Most of the year, from October to June, general steering winds in the upper atmosphere are from the west, the northwest, and that air is dry. Once we get into monsoon season, July, September, that switches, that shifts, so that we're getting air from the east, from the southeast, from the south, where the moisture is. So when we have that high pressure that I just mentioned, sets up in just the right situation, moisture sources are to the south, southeasterly flow brings that into our region and allows thunderstorms to fire, typically on the higher terrain. There they are. And then as thunderstorms grow and then they die off, they send what we call outflow boundaries down into the county. When those collide, those create more thunderstorms, and that's how we get an active monsoon day. So that's a quick, very idealized, kind of perfect picture monsoon setup of why it rains, how those storms form, and really the larger scale circulation. So the significance of the monsoon, the season runs officially from June 15th to September 30th. Now that exists as a coordination effort. There are a lot of scientific ways that you can track monsoon moisture, whether or not it's present, when it arrives, kind of the impacts. But for the sake of safety and coordination across agencies, we decided that June 15th to September 30th calendar days is a broad brush, easy way to define when we start, preparing for monsoon impact. Typically, that onset isn't until about the first week in July when we start seeing the dew points rising, when we see moisture present and storms firing. And if you look over at this climograph here on the right, you'll see July and August. These two right here are real heavy hitters when it comes to normal precipitation. And we actually receive 30 to 40% of our annual rainfall in the monsoon period. That equates to 2.43 inches at Phoenix Sky Harbor and 2.96 inches across our entire alert network. So it's a really significant season. Now onto the hazards. In this talk, we're going to talk about the monsoon outlook, whether we think it's going to be wet, whether we think it's going to be dry. What's it going to look like? Is it going to rain at my house? Is it going to rain at my neighbor's house? That's always fun to talk about, but one thing I want to really pound in is regardless of how much it rains or how much above average it is, these hazards that I'm about to talk about they exist. They're present. They're going to happen anyway, regardless of whether we have a wild monsoon or, you know, a more dead one. So how do these hazards form? I want to just show you. This video is awesome. I never get sick of it. We show it every single year. This is from our neighboring county to the south. This is from the University of Arizona. And I want to just point out right now, number one, you see the sun coming up right now. I talked about solar radiation. That's fuel, that's energy. Surface heating is really important for those monsoon storms to form. So that's number one. And then it's kind of hard to see, but you can see that terrain along the bottom, and it'll get brighter and you'll be able to see it a little bit better. That's an important part for storm growth. Mountains are almost like free uplift. When air moves up those mountains, it can move up and then form those storms, excuse me, on the higher terrain. So there are kind of three life cycles of a storm that we're going to talk about, and we're approaching the first one here in just a few seconds. Watch those mountain peaks right there. See it in the back. What you're seeing right now is air moving up those mountains. It's starting to condense, it's forming clouds, and we are in our developing stage for a thunderstorm. This stage is defined primarily by uplift. It's by air moving upwards. There's typically not rain at this moment in time. But as those storms continue to fire, they grow, they get to the very top of the atmosphere, you see them spreading out. Those are storms at the mature phase. That's when you start to have a balance of updrafts and downdrafts. This is typically when we see most of the monsoon storm hazards, like heavy rainfall, hail, frequent lightning, things of that nature. And you can see there, like I mentioned, when storms fire, when they die off, they send out those outflow boundaries, and it's almost like a self-sustaining cycle, and those storms just keep on popping and popping. And then as they die, we get to our dissipating stage that you'll see in just a little while. So those clouds move really high up and you can see them in the distance, but after the storms die, you have those anvil clouds, but it's all downward sinking air as those storms are dying off. They keep on going, and then the sun starts to go down. You get a little bit of remnant sprinkles, remnant cloud coverage, and then the sun goes down and we do it all again the next day. So, monsoon hazards, what do you need to look out for when you read the weather outlook or you check the National Weather Service? What are the things that you need to be prepared for if it's going to storm that day? Number one, it's in our name, floods. Water is incredibly powerful, and it's very dangerous to underestimate it. When you look at this right here, look at those roads, the way that this has been eroded by the waterways. 6 inches of flowing water can knock a person off their feet, and 18 inches will float just about any vehicle you could think of, even your lifted Toyota Tacoma or Ford F-150, regardless of what it is. That water will take it away. It's powerful. And even if you know that water may only be 3 inches deep, you might not know what the road looks like underneath. Water over time can erode the roadways. It can make what used to be a daily commute look completely unrecognizable. Next up is winds. So like I mentioned, as those storms grow and they die, they send out wind. Basically, they create strong winds at the surface. This was from monsoon season 2 years ago over by McCormick Ranch neighborhood. You see those velocities. So this green is moving towards me, the red is moving away. Those are intense winds that are ripping up trees that are 8 inches thick. I mean, it's powerful winds. You don't want to be outside around all this flying debris when that's happening. And then dust storms. These are typical in early monsoon season, so June, July, August. Typically, they precede wetting rains, so while the dirt is still dry, and your visibility can drop in an instant. It's important to know when you're driving what to do. Pull over to the side of the road. You want your lights to be off. You don't want anyone to think that you're a lead car and that they can follow you. So that's an important thing to keep in mind. Up next is lightning. Just about every single thunderstorm will have lightning with it and have that potential lightning threat. So it's prevalent obviously across the entire state, but especially within the Phoenix metro. Every single monsoon season, even on those dud years, still a threat. And most importantly, unfortunately, heat is the deadliest and the most impactful of all monsoon hazards. And it's amplified by the moisture present. So we all know it's hot. When it gets to May and June, it's hot, it's miserable outside. But when that moisture arrives, it becomes muggy and kind of soupy outside, and we know that. But it also adds an elevated threat because when it's moist outside, your actual biological mechanisms that cool you off can't do it as effectively. So understanding the heat index and how heat combined with moisture can actually put you at a higher risk for heat stroke and heat exhaustion. And then with that, I'm happy to turn it over to Johnny to talk about the climatology and a little more of the outlook.
All right, yeah, it's always important to have reminders of what the monsoon can bring. So as Hannah was mentioning, so whether it's a dry outlook or a wet outlook, those hazards come all the time. So before we get into the outlook, which is really what everyone's interested in, is it going to be a wet monsoon? It's good to know kind of what we can typically have to compare. What is wet, what is dry. So this is going to be something different than we've shown in last outlooks, and we're going to really break down the climatology of how wet it can get or not get in the alert network. So the alert network is really where all this data is derived. We have a wonderful team that's managing this. And what's fantastic about this is you're not going to see this kind of density of rain gauges really anywhere else in Arizona. And that's advantageous to us because we want to track those thunderstorms that are smaller scale. So even with this amount of rainfall, rain gauges, we have 300, almost 400. Even then we miss some of these thunderstorms, but we get a good idea of what's happening on any given day. So we've seen this before. This is kind of a way to summarize all those rain gauges into a single value. It is useful when we look back to 1981, when we really started getting enough data to even make this kind of plot. What you're looking at here is the mean rainfall during a monsoon. And the key thing here is there's a lot of up and down. So one consistent thing about the monsoon is it's inconsistent. That's just the nature of the monsoon in the desert Southwest. But again, we always get some kind of rain, and this is what is being shown here. Kind of things I want to point out, though, is really the last decade has been even more variable than usual if you go back through the whole historical record. So some of our wettest and driest periods have occurred really in the last decade. But we can do a little bit more digging down into how wet and dry we can get. So typically, again, just to go back, this is how we usually talked about the alert network. Now we're kind of moving forward into what's going on. There's flavors to any monsoon. So we don't have enough time to go through all this table, so I will point out some highlights. But the key here is on the far left column, going back from 2000 to 2025, so 26 seasons, we can actually see when were those wet years, when were those dry years. And again, you see really the last decade, those anomalously dry periods, anomalously wet periods have really been stacked in the last 10 years or so. But what we can do, again, we're trying to figure out more about the monsoon and its behavior. What we can do is actually break it down from an onset, a core, and a transition period. So the monsoon, we talk about thunderstorms, but there are more than one way to get a thunderstorm around here. So we've seen it last year, right, where we had a tropical cyclone influence. We had what Hannah talked about with the heated mountain. So that's more of a local effect. We even have other situations where we have passing disturbances that are tropical easterly waves. So there's more than one way to get a rain day here in the county. And so again, this is looking at rain days and trying to see if it's anomalously wet or dry. It's very useful to get a good picture on the different kinds of monsoon seasons you might experience. From here, we can actually start building an outlook. So again, on the left side, we have the June through October, which we traditionally talk about, but now we're going to move into looking at the onset specifically, the core, which is July and August, and the transition. This does include October. So this is another kind of change from what you've traditionally hear about. Hannah talked about how we talk about the monsoon being June 15th to September 30th, but we know we get our heavy rain in October, and some of our most impactful rain has happened in October. Looking at 2018, one station here recorded over 7 inches in one day, which blows out any other day in the rest of the monsoon. So from a monsoon standpoint, it's actually important to actually look at from June through October. This is what this is showing here. So now let's take this table and kind of dive into some more interesting things. So this is actually looking at the alert network. Again, just the rain days. On the top plot here is going to be the alert network as a whole. So kind of some interesting notes here. We average about 72 days of rain in any given monsoon. So if you look from June through October, that's about half the days. This might be surprising to a lot of folks out there that we get rain somewhere in that network that we have, those almost 400 rain gauges. About half the time between June and October, we get a rain day. That's awesome. However, if you live in the valley, it's a little bit different story. It is less. We know that, right? We look around us, more thunderstorms exist in the mountains, and it takes a little bit more effort for those to actually make their way in the valley. So 54, so about a third of the period we tend to get rain. Also interesting to note is when the onset and demise of our thunderstorm chances are, right? So on the alert network, around mid-June, we already see thunderstorms the last few days. That checks the mark there. For the valley, it tends to be a little bit later in the month. That makes sense too, but we've already kind of hit that mark as well. But the important thing here is the last day of thunderstorm activity actually is closer to Halloween. So again, emphasize why we want to actually look statistically for rainfall data from June through October. So we can break it down by onset, core, and transition. Very interesting stuff here. A lot of our rain days do tend to happen in July and August. That's when that monsoon circulation is in full force. We usually have a really good tap with the subtropics. That makes sense. Gets a little more variable on the ends in June and October. But October, don't discount it. We've had some significant rainfall events when we make that connection with tropical activity into Arizona. So another thing I want to point out here too is this idea of a burst and break period. What's cool about the monsoon is that really one day is always a little different than the next, right? You never really have a string of the same type of day. And it keeps forecasters like us on our toes. And if you look at the studies and the research and just observationally from a forecasting standpoint, you do have these burst and break periods. Basically what this is saying is that the monsoon is not stable. So when it does rain, it's kind of cool. We actually have our rain days tend to last about 5 days. And we've seen this before in the mountains. It tends to be about a week period where we see growth. And then all of a sudden we get that drier period. So again, this ebb and flow of monsoon moisture in the desert Southwest. And that's just a little less for the Phoenix Valley, which makes sense. So I got two more, one more after this. And this is actually looking at not just rain days, but now heavy rain days. This is that ½ inch, right? So this is when, from a forecasting standpoint, you can get ponding on the roadways. It's inconvenient sometimes for traveling wise, especially if it happens in the Metro Phoenix area. Flooding is can become an issue, right? So the network itself averages about 35 days a year. And then for the Phoenix Valley, about 20. All right, so let's go ahead and get to the more extreme events, the 1.25 inches. So this is the significant rain. These are the ones that usually the news stations will run stories on. This is the ones you'll talk about to your coworker the next day, the one that you remember for the season. This is the 1.25 inches, and it sounds very specific. And the reason for that is this is actually the cutoff when you look for Phoenix Valley rain gauges for a 10-year recurrence interval. So this is actually a good mark when you start seeing more flooding otherwise, because a lot of our flood control structures outside of dams are built for that 10-year design. So this is a good mark when we see this hit within the 1, 2, 3 hour window, very heavy rain. This is usually when we'll start issuing alerts, messages. The Weather Service might be issuing their flash flood warnings. This is usually the cutoff point here. And if you look at the network, about 16 a year, and then for the Phoenix Valley, about 6. But probably the big takeaway out of all this is whether dry or wet season, look at the minimum for the Phoenix Valley. Over the last 26 seasons, we have not had a season that did not experience this significant type rain event. So yes, the numbers may change from season to season, but the point is what we do for flood control and others who are involved in flood emergency response, every year we have something to deal with. All right, the big reveal. All right, the Monsoon Outlook 2026. What are we thinking? This is so cool. Here we go. So I'll let this soak in just for a sec. And so this is something a little bit new as well. We haven't before put official numbers when it comes to what were expectations for rainfall. So again, rainfall days, and now we're going to break it up into June, which is the onset, the core, and transition. This is what we're thinking here. So really the idea, and you've probably already heard of it, of a wet outlook, yeah, that's what we're expecting. So the sequence here might be a neutral, wet, wet. So we are expecting the monsoon to ramp up. We've already had some signs of it already in June, but we're really expecting that July, August to be fantastic. And then the transition period also to be fantastic. And I'll talk about why that is in a sec. The elephant in the room is El Nino. That's going to be a huge player. And then also we can actually start looking at how much heavy rain days and significant rain days. So yeah, over 51 heavy rain days and then significant rain greater than 25. So yes, we're expecting 2026 to be one of the more wetter ones we've had in the 21st century, really. Why is that? Here we go. So let's break it down. There are a few key things to look at in any given monsoon for the outlook. The first one is going to be, we talk about this a lot, is the snowpack. It was such a dry winter. We had a snow drought. You heard that in the headlines. You heard it from the Weather Service folks. You heard it from NOAA. It was true. We had it's actually historic dry snowpack, winter precipitation. And we even had that March heat wave, for instance. And that was really the nail that really took away a lot of the snowpack that did exist in the West. And so what you're looking at here, just look at that black line. This is looking at snow water equivalent over the Colorado River Basin. And what the important thing there is, when you see that steep drop off that occurred pretty much in mid-spring after that huge heat wave, we lost all that moisture in the landscape. We lost the snowpack and everything else. The reason why that's important is because what Hannah was talking about, what feeds the monsoon circulation is that heating of the land. Without the snowpack and soil moisture to eat up that solar energy, now that monsoon circulation can set up faster. And we've actually already seen evidence of that already in June. So that's a check mark there for a wet season, at least for the start. Another thing to consider is actually right down the road from us, the northern Gulf of California. It's a small little body of water, but it's so important for the monsoon moisture as a monsoon moisture source. So you compare it to the Gulf of Mexico or the Eastern Pacific. It looks so small, but it is very important. It's this narrow stretch along the Baja that is just much more warmer already than the Eastern Pacific. We want warm water. Warm water is evaporation. It can start feeling moisture into the atmosphere to work with on the terrain for thunderstorms. This is important. The key, though, for the northern Gulf is there's actually a certain threshold of sea surface temperatures that we're actually looking for. It turns out to be around 85 degrees. That is very specific, I know, but there are studies that lined up, past studies that have shown that around 85 degrees along the Gulf, you actually break up the marine inversion right along the surface of the Baja. Why is that important? Well, when you break up that inversion, now all that moisture that's pent up can be released into the troposphere. This is fantastic because what this does is allow those thunderstorms to start developing on the Mexican mountains there, the Sierra Occidental. Why that's important is because another way to strengthen the high pressure circulation and get the monsoon circulation going is actually wet convection. So what Hannah was describing was the heating of the land. That's, you're driving up a lot of air mass in the mid-levels, you get the Coriolis effect, you get the high pressure circulation. Another way to keep mass moving into the mid-levels is actually thunderstorms themselves. So there's research that shows that when you have an early onset in Mexico, the monsoon circulation naturally wants to start moving north closer to us. That's what we want. We want that high pressure circulation to move further north and even past us in the Four Corners area. So the reason why I show this as well is we're hitting that check mark as well. We've already reached that point. I looked at it this morning. We were at that 85-degree mark. So there's going to be some fluctuation, but the point is this is now a moisture source for us to work with. All right. So that was local, regional. Now let's kind of go global here. Just so much discussion about El Nino, super El Nino, big El Nino, all this stuff. And yes, we are already officially in El Nino as of June. and we are likely to even get into more of that category where it's a strong El Nino. So comparable to one of the strongest ones we've had on record is 97, 98. 2014, 2015, or 2015, 2016 was also strong, and then 82, 83. So we're actually going to start moving into the territory that kind of correlates with those type of years, which is kind of cool and very impactful for us, can be. So what you're seeing here on the plot here, just to show that yes, these blues are anomalously cool waters out in the East Pacific, in that red zone there, and then we got that jump. So the idea was we're going to have emerging El Nino conditions, and that's what happened. So we're officially in El Nino. What is El Nino? There's a lot of questions of what does that even mean? All right. So El Nino was discovered quite a while ago, and really what it was looking at is pressure patterns across the Pacific between the West and the East. And so someone looking at some data realized that there tends to be a flip-flop between high and low pressure when it comes to Indonesia and then the East Pacific near Peru. So when you have that flip-flop, the waters tend to respond. What's happening here in El Nino is that specifically the trade winds are very important. So when the trade winds along the equator weaken, it allows warmer water that's being pulled up on the west to start moving east. It's basically like releasing a dam, so to speak. And all that hot water, warmer water, on the surface starts moving back into the Eastern Pacific. Hot water, again, you want to increase evaporation. Evaporation leads to thunderstorms. Thunderstorms is low pressure. Those thunderstorms themselves are lower pressure, right? So you get that pressure imbalance when El Nino is in full swing. This is a cool graphic here. So this was made by NOAA, and it was released when they announced that officially we're into El Nino territory. What this is looking at is the anomalous waters, the heating from January to now. And what you're seeing here is that you see the blues, and then you get that blossoming effect. The trade winds weakened. Now we have this warm pool developing on the East Pacific. That's very important for us because this now leads into other outlooks. We're specifically looking at the monsoon, but we'll talk about the hurricanes, right? The tropical cyclones. We already talked about how they can have a huge influence on the end of our monsoon rainfall totals, right? So sure enough, yeah, El Nino, we're expecting a higher activity in the Eastern Pacific. And we already had 3 as of mid-June. And there's signs that there even could be development within the next couple weeks or so. However, on the Atlantic side, it tends to be inverse, but that's okay. Because if you look at the monsoon circulation, we're really trying to tap into the East Pacific here. And keep in mind too, we don't need direct hits. We often do not get direct hits from tropical cyclones, but just their presence alone will actually allow all that evaporation and subtropical moisture to pool. So when the monsoon circulation starts wobbling and hits just right, it basically gets sucked in. So really what we're looking for is just the availability of subtropical moisture. We want that thunderstorm activity in the East Pacific. That's a good thing. That's another thing that's going to contribute to a wetter outlook. This is kind of cool. So this is what happened in 2018. So 2018 is looking like a decent year as an analog for what could we expect in 2026. 2018 was also a situation where we had a very dry winter. If you look at the headlines back in 2018, they're actually eerily similar to what we experienced this past winter. Record heat, record dry, snowpack dropped off early, all this. And we moved into an El Nino into the summer. So we're following that kind of progression here. Again, the sample size is small, but it's good to look at potential evolutions of past monsoons and what we experienced. 2018 showed this. This is what happened throughout the entire 2018 season here. Really above average, 25 tropical systems, I should say. And we can see that, yes, these are the tracks that are moving into the Baja area. We're right there. So yes, we want that activity to start moving into our area. And if you guys remember, we keep track of certain big events. And so maricopa.gov/weather, we actually have publications of past storm events. 2018, we made one for Hurricane Rosa. This happened in October, and it was very significant. I mentioned already that we had that one station at 7 inches in a month. That was during that event. So Hurricane Rosa was very impactful in 2018. And really the entire East Pacific Basin was incredibly active. Another thing to keep in mind too is if you look at any given year, whether it's an active season or not, these are all numbered. And if you look at the numbers that move into Mexico or our area, they tend to be low numbers or high numbers. The reason for that is the East Pacific hurricane season already starts in June, whether the monsoon is there or not. And so what can happen though is that if the pattern over the southwest is right, we can start dragging in that activity. So in June, there's a good potential because we still have winter spring-like troughs that can dig down and kind of push that moisture north. As that monsoon circulation really builds, July, August, even September, we tend to like knock that down. And then all of a sudden, late September and October, we get more of that jet stream sagging far south again, and you get those hybrid type events like 2018 in Rosa. That tends to bring in the East Pacific activity if it's still around during that time. So this is why we tend to see early tropical activity events and late. All right, big caveat to all this. So the monsoon circulation itself, I mentioned with those break and burst periods, it's always on the move. So our area can be can be screwed, I guess, when it comes to thunderstorm chances. And what I mean by that is if the monsoon circulation itself is right on top of us, like this was taken in 2024, that downward motion underneath the high tends to heat and suppress thunderstorm activity. So around you could be doing fantastic, a banner monsoon season or a very active period. But if you're underneath that high, you tend to miss out on a lot of the rainfall potential. But this high tends to move around a lot, right? In 2024, it just happened to almost park on top of us for a long time. We set a lot of heat records. This is a concern when it comes to field work, the public outdoors, just doing their normal day-to-day activities. This is where you get that heat dome talk, heat waves, that kind of situation. The issue is this suppression of thunderstorm activity is usually at mid and upper levels, not lower levels per se. So we can still have some monsoon moisture to work with. So Hannah already talked about the influence of moisture with heat. So the heat index rises and that risk also rises as well. So this is unfortunately one of the worst case scenarios for us if a high parks on top of us. So yes, the best storm potential does tend to be around it because this is our pump. This is kind of a cool graphic here. What you're seeing here is satellite water vapor. The blues and the whites and greens, that's where you get thunderstorm activity. That's where you get clouds. That's where you get moisture. And you see, it's crazy. This is around 20,000 feet in the atmosphere or so. And you can see that there's pulses. This is about over a 2-week period. So you get these blow-ups of thunderstorm complexes and whatnot. You get the westerly winds that are bringing drier air from the far northern Pacific. You get a lot of stuff moving on, a lot of moving parts when it comes to monsoon. But again, that high is so critical. Where that high moves means a burst or a break period. All right, monsoon forecast expectations. So again, another caveat to all this. This is the outlook. We talked about the outlook being wetter than normal, and we have really good reason to believe that we are going to experience a good uptick in thunderstorm activity and heavy rain events. However, it's good to just know the limitations of modern meteorology. And really, it's to understand when we can start answering certain questions that folks might want to know. Like, are we going to have a thunderstorm outbreak, right? Well, we can start getting a hint of that around between 3 and 7 days. I know this is kind of specific too, but given the current day and what we know and our modeling capabilities and whatnot, this is about as good as we can do. So I flip back here, the models are trying to capture this. Okay, that's a lot of movement, that's a lot of activity, there's a lot of nuances. So small things can make big differences down the road. So that's why the models tend to go haywire after about a week. That's just a limitation that we have in the today. Moving forward though, 1 to 2 days, we can actually start getting a really better idea. So this is when we'll talk about in our outlook discussions, like, hey, we're having increasing confidence that a moisture source is moving in, whether it be a tropical cyclone, whether it be an easterly wave, or just monsoon circulation just recirculating, all of that. We can have an idea of a flooding event could be on the way, imminent. Moving into the 12 to 3 hours, this is when our outlook discussion is already starting to discuss where in the county, what parts of the state are going to be hit. So this is really when it's important to pay attention to some of our predictions, our values. Those QPFs, quantifiable precipitation estimates, this is coming from the models, our experience, what we're seeing in the large and local scale patterns, how everything's coming together to introduce a heavy rain threat. So again, our outlook talks about this. And then within 90 minutes onset, this is actually when we're on the desk, the work desk, we're issuing our alerts, again, the Weather Service there, warnings and whatnot. And through all this, we're really trying to keep an eye on the radar. This is when we're in the moment. So again, this is kind of that 7-day to the situation, a flooding event. So now, that was the main outlook. But again, there's a lot of moving parts to any monsoon forecast. So even right now, the consensus is wet, but the idea here is, everyone has maybe their own thoughts.
Yeah, why don't you go back actually to your quantitative prediction here?
Okay.
Johnny went out on a limb. He told you how many days in each part of the monsoon right here. So overall, we're expecting wet. Keep in mind, this approximately 87 rain days, it's not going to rain at your house 87 times
That's a
a
good
month.
point.
I mean, if it did,
That's a good point.
oh, that'd be incredible. What we're just trying to get at here is 87 days where there's a recorded measurable tip within the network. So that might be on top of Mount Ord up on the northeast part of the county.
Yeah.
It might be down in Gila Bend, or it might actually be at your house, Joe. And you're like, yeah, I got rain. So keep that in mind. Same when it comes to this during the core onset, like 50 rain days. You're not going to get 50 probably again at your house. So the whole important part of this and all this research that Johnny shared, that's really interesting, is to realize that, again, that the monsoon is variable, but it's important to keep a regional look. We don't want to get myopic and just kind of really end up focusing on one particular spot. Again, Phoenix Sky Harbor is our main reporting center for the National Weather Service. There's a long period of record that goes back into the 1800s, and that's important. It's really important not to go back historically, but also to look regionally. And so we can learn so many more things about the monsoon by breaking it up into a regional perspective. So back to this whole thought about Monsoon Outlook. I have never been able to give you guys these kind of numbers. So that's kind of cool. What my overall thoughts on this, though, is I think there are very similar parallels to 2018, which he brought up, maybe even 2014. And if you take yourselves back to those years, we had early onsets, false starts, where the monsoon storm activity started up, kind of like what we had this week. And now we're going into a dry period, and then we're going to maybe even an extended dry period into July.
It could be. Yep.
But the overwhelming, factors that we're seeing is that there should be some type of ramp up that starts happening late summer and into the fall, whether that's due to tropical storm activity, whether it's the monsoon ridge finally planting itself. And those are the events that Tom Rankley likes to talk about. Those are the ones we see once, 5, 10, 15, 20 years that make or break a career, where again, we could get a really one big heavy event like Rosa that happened right on September 30th into October 1st, 2nd, where if it would have happened a day earlier, it would have gone into the record there, and that would have been one of our wetter monsoons. Because most of the rain fell on October 1st and October 2nd, it was just like a right around normal monsoon. Again, last year, October 12th through the 15th, again, that event actually was even earlier. It was like the 10th through the 15th. That was record-setting rain. Again, we're seeing a lot of these kind of parallels, a steady ramp up. So I would go with, you're probably all going to get really annoyed in early July that it's not raining, like we told you how active it's going to be. But come August, September, and into October, and then really the meat of what Johnny was getting at with El Nino this winter. If things pan out well, we should see an active and hopefully wet winter.
That's true. Yeah, that's one thing that is important to watch out. We're focusing on the summer, but the emerging El Nino part is really important for water supply going forward. So November, December, January, February, this is actually looking promising for Arizona and the Southwest in general. So even going beyond a potential wet fall, it'd be great to have that wet winter too. We need that. You bring up 2014, and the issue with 2014 I showed you guys earlier on the map is that high was sitting right on top of us. So if you actually dig into the data a little bit, the alert network did okay, actually, if you look in the mountain environment. It tends to be more resistant to a full thunderstorm suppression, but the valley really missed out. So that's actually a year where we had a huge disparity between valley and mountain. So that can happen too in a monsoon, and 2014 was a good example, or 2024 was a good example of that as well.
So, but if I'm going old school TLDR, looking at our social media group back there, it'll be wet. Just take some time. So be patient. All you social media folks, be patient. The rain will come.